All right, so what if I give you a polynomial and I say, hey, we want to factor this cubic. And obviously we can't just factor it in our heads. So what do we have options of here? Now, we could just guess. We could guess factors. The smart thing to do when you're allowed to would be to graph it, right? So we could graph it real quick, right? We've got x cubed plus 5x squared minus 2x minus 24. So, and we can see what our factors are here. So minus 4, minus 3, 2. Great. So I'm just going to pick one. We're going to pick the minus 4. And we're going to pretend that we had guessed this thing right off the bat, right? So we could say, let's go back. Don't know why does it do that. Nobody knows, right? 1, 5, negative 2, negative 24. No missing terms here, right? So we're just going to say, hey, minus 4, so it's 1, minus 4. Let's see, negative 6, 24, 0. So of course that's a factor. So that means we've got x minus negative 4. And we've got x squared plus x minus 6. And that one, we really don't need to keep going here. We can say, oh, I know how to factor that. What are factors of negative 6 that add to 1? Well, we've got plus 3 and minus 2, right? And we're done. We've factored f of x. Great. Okay, but what if we can't graph our function? What do we do? Do we just guess random numbers? Not so much, because that's a lot of guessing, right? A lot of numbers to pick. So we're going to use what's called the rational zeros theorem. In this case, we've got a very generic polynomial, right? We've got our leading term, which is a sub n, x to the n, so some power, the highest power in the polynomial. And of course, we've got our constant term, and we've got everything in the middle. Okay, so this theorem says, now, special case, we have to have the coefficients all be integers, and they have to be real. Okay, so we are looking at rational numbers denoted as p over q, where p and q are called what's called relatively prime, which means they have no common factors besides negative 1 and 1. And if p over q is a 0 of f of x, then p is a factor, of a sub 0, and q is a factor of a sub n. And we're going to kind of reverse that and say, well, then that means if I list out all the possible factors of a sub 0 and all the possible factors of a sub n and make this p over q, all the different possibilities, well, it might be a lot still, but it's a whole lot less than an infinite number of numbers to try. Okay, so let's do that. So here we've got ourselves a 7th order polynomial, right? And so this is our a sub n, this is our a sub 0, and we're going to want to remember that our p is the factors of the constant term, right? And our q, our q is the factors of the leading term. Okay, so what are our factors of 12? We've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, this is going to be a lot, plus or minus 6, plus or minus 12, and of course q, the leading coefficient is 1, so we have plus or minus 1. So we can list out all of our possible zeros pretty quickly. Q over q, we've got 1 over 1, plus or minus, 2 over 1, plus or minus 3 over 1, plus or minus 4, 6, and 12. So while that is still 12 numbers to try that might be rational zeros of this function, that's narrowed down our choices quite a bit. Okay, so we've got another example here. Let's see. All right, so again, this one's a third order. We need to list out our P possibilities. So remember that's coming, from the constant term. So we're looking for factors of 9, negative 9. So we get plus or minus 1, plus or minus 3, plus or minus 9, right? And our Q, we've got plus or minus 1, plus or minus 3. Okay, so we're looking at all possibilities of P over Q, right? So we're looking at 1 over 1, 3 over 1, 9 over 1, right? And then we've got 1 over 3, 3 over 3, but we've already got that one counted, and 9 over 3, but we've already got that one counted. And so that brings us down to only 8 options for our real rational roots. So there we go. All right. And that's actually a really good place to stop, I think, given the time. The next video is going to talk about the fundamental theorem of algebra.